Hello friends, today we are discussing the pedal equation or the PR equation. So this pedal equation is also known as the length of perpendicular from the pole to the tangent. So here we have the figure of that. So here you can consider we have drawn an initial line OL and OP is the radius vector R at the point P of R comma theta. On the OP we have drawn a curve R of F of theta, polar curve. So we have done a tangent to that such a way that we have extended this length of perpendicular that we have joined for ON at the point P. So here phi is the angle between the radius vector and this tangent. So description part here we have consider a curve R is equal to F of theta and a point P of R comma theta on it. So we have considered phi is the angle between the radius vector and the tangent. So also we have drawn this tangent perpendicular to ON from the pole to the tangent at the point P. That is ON here we are considering as P. Okay, you just observe here the triangle OPN. So we have to consider sine phi. The triangle OPN sine phi is equal to ON by OP. So that we considered. Next, you can observe here from the triangle OPN in this figure OPN sine phi, so sin phi equals to ON by OP. So from the figure, we have considered ON as P and OP as the radius vector. So that we substituted here. So sin phi is equal to P divided by R. So now from this we have to simplify. If we'll take the cross multiply, we'll get it as P is equal to R into sin phi. So from this we have to define what is the length of perpendicular from the pole to the tangent. So next step is we have to square on both sides for this equation. So p square is equal to r square into sine square phi. We will get it as. Now if we'll take the reciprocal of this equations, we'll come to know 1 by p square is equal to 1 by r square into 1 by sine square we replaced as cosecant square phi. From the identities, we can make that cosecant square phi as 1 plus cot square phi. So here 1 by p square and 1 by r square as it is, in the place of cosecant square phi, we replaced as 1 plus cot square phi. So this value we can substitute with the help of the equation. What we know, the angle between the radius vector and the tangent. So from that equation we have angle between the radius vector and the tangent is given by tan phi is equal to r into d theta by dr. We can convert cot phi as 1 by r into dr by d theta, or we'll convert cot phi as 1 by tan. So therefore here we have 1 by p square is equal to 1 by r square, 1 by r square. Here 1 plus cot square phi we have. What is the cot phi here? Cot phi will be 1 by r into dr by d theta. So cot square phi nothing but 1 by r square into dr by d theta whole square. So this is the equation we got by replacing the cot phi. So therefore 1 by p square is equal to 1 by r square into 1 plus cot square phi. We have replaced this equation. So if we introduce 1 by p r square inside the flower bracket, so here we have 1 by p square is equal to 1 by r square plus 1 by r to the power 4 into dr by d theta whole square. So this is the equations we are using, the length of perpendicular from the pole to the tangent, or pedal equation or the PR equation. Sometimes for the given equation we can use P is equal to R sin phi also. If we are able to find phi directly, then we will use this formula, that is P is equal to R sin phi. If not able to get phi directly, then we will use this formula, that is 1 by P square is equal to 1 by R square plus 1 by R to the power 4. When we multiply R square this, we'll get 1 by R to the power 4 into dr by d theta. So this is about the pedal equations, or simply we will call the PR equation. Thank you.